In this video, I'd like to talk about factoring polynomials using complex numbers. And in previous videos where we talked about factoring polynomials, we came across something known as a difference of squares. And we determined that this could be factored as a minus b multiplied by a plus b. And you can verify this by redistributing on the right hand side, and you'll see that the middle terms cancel out and we just get a squared and minus b squared. Now, for this video, I want to focus on what happens if we have a squared plus b squared. So a squared plus b squared, how do we factor a sum of two squares? And for this, we need to incorporate the ideas of imaginary or complex numbers. And the key idea is to remember that I is the square root of -1. This is the imaginary unit. And if we square this, we essentially cancel out the square root and just get -1. So we can rewrite this a squared plus b squared as a squared minus negative b squared. And the reason we want to write it like this is so that now we actually have this difference of squares, which we know how to deal with, and we have this minus b squared. But minus b squared is really just -1 multiplied by b squared. And we know that -1 is really I squared. So we can rewrite this as a squared minus I squared times b squared. And since we have a product and they're both squared, we can rewrite this as a squared minus I times b squared. And you can verify that this is true by multiplying IB times IB, multiplying it by itself, and you will get back I squared times b squared. But notice that now we have this difference of squares and we can apply the formula, where in this case, this is like our b from this formula, so we can just plug everything in, and we will get a minus this expression without the square multiplied by a plus this expression without the square, IB. And we can verify this just to make sure that this actually makes sense. So let me just make a little bit of room here. And we'll verify this by just multiplying it out. So we'll multiply a to both of these terms, and this minus IB will multiply both of these terms. And we get a times a, which is a squared, a times IB, which would be plus AB times I. And we would have minus IB times a, which would be minus a times b times I. And lastly, we have minus IB times positive IB. So we get I times I, which is I squared, and b times b, which is b squared. Now, we know that I squared is -1. So we can just substitute that in here. And let me just make a little bit more room over here. And we'll continue working. So notice that the middle terms with I in it, the imaginary terms, these will cancel out. So we just get a squared. And here we're subtracting I squared, but I squared was -1. So we're subtracting a negative, which is the same thing as adding. And this will just become 1 times b squared, which is b squared. So we can verify that this formula actually makes sense. So let me just rewrite it, that when you have this sum of squares, this can be factored as a minus I times b multiplied by a plus I times b. And in the next video, we will look at a specific example where we have this sum of squares and we need to factor it.